Welcome to the Ortho Joe Show, a joint production of the Journal of Bone and Joint Surgery and OrthoEvidence. In our world, orthopedic research is king, and current topics from our respective publications are analyzed weekly. Here is Mohit Bhandari from OrthoEvidence and Mark Swinkowski from the Journal of Bone and Joint Surgery.
Well, good morning, Mo.
Good morning, Mark. How are you?
I am really well. You know, I spent the last 6 months when we would open our conversations for Ortho Joe whining about the weather.
Yes.
And it was 77 yesterday in Minnesota. So, but it did bring up a very, I get existential question for me that I'm concerned for you, my dear friend. What do you do to keep your brain health up to speed when there's no ice chop through and stay submerged for 5 minutes? What do you do at this time of year?
You just kind of melt. You just kind of melt away, and you just enjoy what our seasons in Canada have to offer us. You know, see, a lot of places don't have seasons, so they have nothing to look forward to, right? If it's just always 80 degrees and sunny, I mean, there's no, it's nice to kind of have the negative 40 to appreciate, the plus 20.
I get it.
Celsius. Yeah,
I get it, but you've convinced me of the value of brain health for this ice submersion.
Yeah, it does help.
So what happens in the summer?
So in the summer, honestly, I just put it on pause. Although I should get one of those ice baths. You can get them, but it's a lot of work. So I just let our seasons, dictate my activities.
Okay,
Probably
well,
not
hopefully.
Perfect.
Hopefully you don't undergo any slippage of your high mental acuity.
No, not at all, not at all. But today we have a great discussion, as you know, Mark, about a very important topic. And if I could just take a second here to introduce Joey Silburt, who works at OrthoEvidence as one of our data scientists. And Joey has been doing a lot of work and a lot of thinking around the issue of artificial intelligence and the host of umbrella topics as machine learning and things that come under it. And I wonder just up front if we should be, thinking more deeply about how information is going to be handled, because we are definitely in a new world. Like more than any other time, I think in my life, I feel we are headed towards something that I don't even know if we understand the implications of. Welcome, Joey, and thank you again for spending a bit of time with us.
Thank you for having me and for the very kind introduction.
Yeah, Joey, so last year around this time, I think it was, 10 or 12 months ago, we had you on Ortho Joe, and you did a really, really good job with educating our audience about the terminology surrounding artificial intelligence. So, but I don't think any of us really understand it anywhere near as well as you do. So just as a refresher, could I ask you to define a couple of terms that are appearing in our literature more and more frequently? So artificial intelligence, let's start with that. I've got 3 others after that.
Sure. So artificial intelligence is kind of like the big umbrella term that defines all the things that we are seeing today. And really, you can think of artificial intelligence as kind of the Star Trek vision, where you have computers making decisions, learning how to mimic human activity, and just sort of performing tasks. So, it's sort of true to the name, artificial intelligence. It's trying to make computers smart and be able to accomplish tasks and make predictions, things like that.
Perfect. Machine learning.
So within the big umbrella of artificial intelligence is machine learning. So it's kind of the biggest chunk that encompasses artificial intelligence. And it's really just like the set of tools that are used to accomplish artificial intelligence tasks, if that makes sense. It's kind of the collection of instruments that allow computers to learn. That's sort of what machine learning is. But, in today's day and age, it's almost synonymous with artificial intelligence. So if you hear machine learning, you should think artificial intelligence. And when you hear artificial intelligence, you should think machine learning. They're almost essentially the same thing now.
Thanks. 2 more. Natural language processing.
Yeah, so natural language processing is sort of a subfield of machine learning and artificial intelligence that's sort of focused on how do we process text or natural language. That's where the natural language comes from in the natural language processing. And it's a set of tools, or it's a field focused on learning information from text and making predictions from text, and doing anything possible using text.
And the last one, neural networks.
So a neural network is, once again, so we have artificial intelligence. Under artificial intelligence, we have machine learning. And then under machine learning, we have neural networks. So a neural network is a type of model, type of machine learning model that is used to accomplish, all of these tasks. So most natural language processing tasks are accomplished by some kind of neural network. And it's really sort of, there are different kinds of machine learning models out there, but neural networks have proven themselves to be the most powerful and the most widespread and the most used. So it's not quite the same thing as machine learning, but in most cases, I shouldn't say most cases, but in a lot of the power that we're seeing with machine learning comes from the use of neural networks.
That's very helpful. If we have you on again, we may start with the basics just so our readers are up to snuff. But I think that last definition really is a nice segue into the large language models. And it's something that really has been keeping me occupied the last 5 months. So Mo, I'm going to ask you to take it from here.
Yeah, I mean, so very, very helpful. But, at a very, so there's a new language. So Joe, we've talked about this back in the day, back in the 1990s, early 1990s, when the word evidence-based medicine came up. There were a whole bunch of terms that we just hadn't heard about, confidence intervals and study validity and all these different approaches, concealment of allocation, things that, that were new languages. But functionally, we're asking fairly fundamental things that for most reasonable people, they'd say, oh, okay, I see why you do that. Isn't a lot of the analysis that we're doing a lot of just what we used to call regression analysis, but it's done at a very high level because systems now can run them at a capacity with the amount of data faster? Like when you say a neural network, do you mean what's happening at the data level? Just so some of our readers, watchers can get a sense of what this is.
Yeah, exactly. So I guess we'll start at the early neural networks, because I think last time I said something to that effect, but the truth is, I'm not sure that's necessarily the case anymore. Anyway, so we'll start from the beginning and unpack it. So a neural network is, you can think of a neural network, if we can all imagine the picture, it's sort of just like a series of circles stacked on top of each other like that. And each of those individual circles in that depiction is its own just kind of linear model kind of thing. So really what a neural network is you're sort of stacking linear models on top of each other. And we can think of this as a way to make complex correlations between some sort of input data, right? So we have a first layer that processes the initial information and then gives you some output intuition about what that information is. Then you have another layer that sort of takes that derived information, processes it more, and then you learn a little bit more about whatever task you're doing, the input data, through these individual layers. And the thing that really ties it together is actually, not to get too technical, but in between these layers, there's something called an activation function. And on a technical level, that sort of injects in nonlinearity, is what it's called. So that's what makes a neural network not the same as a linear model, because you have this additional nonlinearity that allows it to make very complex relationships. That's kind of
right. But it's like the mathematics and statistics that are happening on a much higher, more complex level than we typically used to do when we're doing it sort of manually ourselves. And it's done in a fraction of a second with big data sets. So I think that's, for our viewers, it's just a way to think about, okay, that's like this is not some new hocus pocus. I mean, it is, but it isn't. It's really founded in data and in the type of fundamental analysis we used to do just at a high level. Now, what is this then? The generative pre-trained transformer, ChatGPT, and then there's a 3 version and a 4 version. Maybe you could just tell us what that is.
Sure.
And then you could just follow up right after that with what's the state of the art right now with respect to chatbots?
Sure. Okay. So there's a couple of things, sort of history that we can unpack with understanding what this is. So ChatGPT, generative pre-training, that's what GPT stands for, is really a process and a model. So I'll try to explain that. So the model is called a transformer. So about in 2017, this new concept sort of hit the AI world. It was called attention. And attention was a new way to process data. It sort of allowed the neural network to understand how data fit together more broadly. So it basically allowed the model to say, let's focus on this piece of data and correlate it with this piece of data. And that sort of one thing was the inceptive moment that launched this whole large language model. So then GPT comes along and it introduces this concept of generative pre-training. And that's really just a training process where it takes the transformer model and it allows it to train on massive data sets of text, because the whole training procedure is to, given the previous set of words, guess the next word in the sentence. So that's the generative pre-training process, where you're just sort of guessing the next word in the sentence. And that sort of training method allowed for these transformer models to train on, giant corpuses of text, learn information from, like Common Crawl is what trains GPT-4, and that's like a significant portion of the whole internet's data. Not a significant portion, but anyways, you get the idea. These are
But basically, just so like again, just to clarify, because like what you're thinking is very simple right now. For many of us, this is new knowledge, right? New information. Right. But when you say that this transformer looks at words. And really, the database on which it's starting to do all of its analyses, like, when you type in something, you get this amazing answer back. Those who have tried it, it's really culling the whole internet. I mean, as long as whatever we mean by the whole internet or close to it, it's taking a chunk of data that we've never had access to previously, or maybe we have, but not in the way that you can use it.
So, like, yes and no. So when I say it's trained on the whole internet, or a portion of the internet, I gotta stop saying that. It's learned about language based on patterns it's learned over that like massive data set. It's not necessarily able to recall on like fingertips all that information, but it in theory it could. It's not really clear how all these things work, but it's identifying those patterns, and that's kind of the point. It's able to really learn a lot about the way humans interact based on these data sets.
Okay, so then who are the two? I mean, I think there are two key players, but can you just tell us, like, who are the players right now, and then what is the current state of the art?
Right. So the major players in the field right now are OpenAI, which is now like they have a deal with Microsoft. So it's OpenAI, Microsoft, Google, and then Facebook, I think, is another big sort of player. So OpenAI was kind of the research group or the firm that introduced GPT-1. They then introduced GPT-2, GPT-3, ChatGPT, which is basically, I guess I should explain, all of these models are really just variants of their initial idea of GPT. They added some new ideas in terms of how to train them. But the real difference, like the real fundamental difference between sort of GPT-1 and GPT-3 is just like sheer size. They just showed that when you take this transformer model and you make it 27 billion parameters or whatever it is, which is like a giant model, it's able to do like an unbelievable amount of tasks. It's able to just sort of do everything. And they also sort of showed through this process that these large language models have some emergent properties. So they're somehow able to learn to perform tasks that they were never actually trained to do. There's like this sort of, I don't know, and this emergent kind of intelligence that has really sort of made them so powerful. So OpenAI is kind of the leader in the field. And so they released GPT 3.5 or ChatGPT, which is what we've all sort of been took the world by storm. We've been using it to do absolutely everything. And now they've just sort of released a couple months ago, GPT-4, which is a new variant of ChatGPT 3. They took what they learned from that whole process, and then they added in image analysis as well. So now GPT-4, not only does it perform better at all of the sort of the natural language processing tasks that, the writing essays and making decisions and things like that, it also can now incorporate image data, meaning you can give it a picture of an image and say, can you describe this image for me? Or you can also do the opposite. You can say, can you generate an image for me that shows, X, Y, and Z, like a clown dancing, something like that. And it's able to integrate between natural language and images. So that's kind of the current state of the art, I would say. So Google is now also trying to catch up with OpenAI. They've released their own new sort of chatbot I think it's called Bard. And it's not fully available to the public, but they're certainly trying to use these large language models. And their kind of vision, I think everyone's sort of vision is going this way, but their vision is to use these large language models as agents, is what they call them. So basically, you have your Google Assistant, you have your whatever you have. So their idea is to incorporate large language models into your Google Assistant, where you say, hey, Google, buy my groceries, right? And it will be able to do it. It'll just smart enough that it can do it. And then the other sort of big player in the field, I would say, is Facebook. And they're kind of taking a slightly different approach. They're focused a little bit more on the scientific community. And then they're also trying to make these large language models smaller. Their kind of whole ethos is, these large language models are 32 billion parameters. It can't really fit on anyone's computer, right? You need like this giant server that's expensive. So they're sort of betting on, if we make them as small as possible, maybe we can distribute them more and find more niche areas. Or that's kind of, I don't know, their set of skills.
Got it.
Well, Joey, that's a very good basic introduction for our listeners and viewers. As I mentioned earlier in the conversation, I have been really occupied with this since late December, early January. And you may know that we just produced an editorial in collaboration with Clinical Orthopedics and Related Research and Bone and Joint Journal and Journal of Orthopedic Research, which is sort of a position statement which had two main features. Number one, these things cannot be authors because they can't defend the content. And number two, that when anybody who is submitting a manuscript uses these tools, they need to declare where and how they were used. But we're really, I guess, semi-panicked about the whole ethical issue of somebody being able to produce a manuscript that really is made up data and getting it into our literature. And so we're hopeful that detection software is going to be available that can tell us in the scholarly publication community when these tools have been used. And what can you tell us about the status of that potential tool?
So there are a couple of tools that are available that can sort of try to make a prediction on whether or not the text that was generated is from a large language model. But I guess my fear is that it's sort of a losing battle in a way. I think these large language models are going to get even better and better. And sort of the way that some of these tools work is they compare a set of generated text to, they sort of refeed it back into a reference model and they compare the outputs. They try to say, hey, is this generated text similar to, a similar output we could generate from the same model, or is it sufficiently different? And I think, as these models get more proprietary and things of that nature, it might become harder and harder to do those detections. And, even if you get, some kind of scoring system, I'm not, there's going to be any number of false positives that might, impact real authors. And that might also be something to consider as well. So unfortunately, I'm not sure I have a good answer on that respect. But I don't necessarily see the large language models as being like a total negative, if that makes sense in that respect.
Yep.
I think for, particularly those for whom English is not their first language, having access to these chatbots sort of levels the playing field, so to say, where they can really focus on the science and not have to spend so much time or worry that their the actual writing of their manuscript is different or substandard compared to a native English speaker.
Right. Yeah, we may be headed for a world where we have to ask for original data sets when a manuscript is submitted, which I'm sure gives Christina Nelson and her team a nightmare about that potential world. But yeah, it's concerning. The whole ethics surrounding it is concerning. And I hope, I've always kind of envisioned this as a good guys versus bad guys, and the good guys helping us to detect the use hopefully would be better than the bad guys who are using it for bad purposes. But it may be a very difficult thing, as you point out.
The thing that kind of, and you alluded to it very early on, Joey, in your opening statement, we started off by saying, what is artificial intelligence? And I think what we're trying to do is they're trying to get computers to think more and more like humans. I mean, that's the goal, right? And the more you can behave, sound, think like a human, the closer we are to this reality or this world. But it's becoming very clear, and I think this is where some of the concerns are. I mean, obviously, there are the concerns we're talking about in the publishing field and just the way data is handled and what's going to happen in medicine. It's going to change the way we practice medicine and surgery, for example. But isn't there a real potential, and I'll let you sort of think about this one, that the computers are going to become much, much, much smarter than humans, and at some point realize humans aren't needed? Is that a possibility? I mean, I'm getting into these conspiracy theories, but like, isn't it possible that like you're already showing in GPT-4, it's doing emergent, like things that we didn't anticipate it would do, it's starting to do and behave differently than we even thought it could do. Are we unleashing something we do not have control of? Is the broad, I guess, more moral or ethical question.
So look, there's certainly a big field, a big subset of researchers and just sort of people in the world who subscribe to that view. And I recently read some headlines that Dr. Jeff Hinton, who's kind of considered the godfather of AI, is starting to voice those concerns as well. The honest truth is I have no idea. It's certainly, I think that the potential is certainly scary. Like I keep coming back to the fact that large language models, this sort of initial idea, the classic paper for large language models only was published in 2017. So think
crazy.
About how I know. So how much has the field of medicine changed since 2017, and then how AI is completely different. The things before 2017 are almost not even like relevant anymore.
Yeah.
So it's breakneck pace at which things are changing. So it's hard to know where things will move in the future.
My editors who we collaborated with to do this joint editorial policy, we're thinking we're going to be writing editorials on this topic several times per year just to try to keep up with the developments. I'm sorry for stepping on you, Mo.
Oh, no, that's so true. And I didn't have much more specifically. It was just more, just thinking about, what I went through, which was, again, mid 1990s, when we were going to take data and combine it, let's say, the term meta-analysis that I think is all our listeners and viewers are pretty comfortable with that term now, you combine data. It was months and months and months of work, right? And then, you'd have to try to, and then there's always this chance you miss something because we didn't have everything done. Just knowing what's happening just with us, in our own kind of work you're doing, Joey, what took us months literally takes us minutes. I mean, we can run thousands of meta-analyses in the back end of OE in a second. And to the point of the chatbot, you start typing in, well, ask a question, it will run the meta-analysis and give it to you rather than just give you a particular study that, this is the most relevant study. Most of our searches right now are, you type into it, you go into a big database of studies and you say, here's what, and they go, here's the most relevant studies, 97%, 94%. That just seems like, as of 2017, is just like, it's not even relevant in the same context as now, which is, I don't want to read 5 studies. I want the answer. I think people want the answer. Yeah. And I think we're going to have to, as publishing groups, really work hard and collaborate to be able to provide answers for our community.
Yeah, well, I think on that note, I wish to sort of assure our audiences that OrthoEvidence and JBJS and the other scholarly publications, we're all over and committed to staying on top of this, particularly the trying to understand the developments, but also the ethical issues surrounding with the idea of preserving the basic tenet of medicine, of us putting the patient first and collecting the best scientific evidence on which to make treatment decisions. So we'll be watching. We're on the wall for the orthopedic community. And Joey, thanks so much. Thanks for all your excellent work at OE.
Thank you.
It's great stuff you folks do, and we're greatly appreciated. And of course, I think you already have one of these collector's items, the Ortho Joe mug. So now you'll get 2. And
thank you.
Maybe you can give it to somebody who is a mentor or somebody who's really in need of a great prize of recognition, the Ortho Joe Traveler mug. So thanks, Joey. Thanks, Mo.
Thank you for having me.
Have a great rest of the day and week.